Hello guys, welcome to Inside Electronics, and in today's episode let's take a look at something that is really cheap. By really cheap I mean this USB charger. You cannot buy anything much cheaper than this because it only cost 15 Indian rupees. That is 15, not 50. 15 Indian rupees. Convert that to whatever your currency is, and that's how much this thing costs. I mean, 15 rupees you can buy it. You cannot buy it retail for 15 rupees. You have to buy a lot of them if you want to get it at such low price. And I got it from one of my friend who is a dealer in all these kind of Chinese electronics things and mobile accessories. And he gave this thing to me because this thing is not working. And when a lot of things, they're importing a lot of things from China, and he's getting this thing for around 15 rupees wholesale, and he's selling them for other stores around 30 to 40 Indian rupees, and they are then retailing to ordinary people for much higher price than that. So basically the manufacturing cost of this thing will be around less than 10 Indian rupees. I mean, these things are such mass produced. And let's take a look at what it says. It says it is European confirmed, but you cannot trust it. It is rated for 1 amps of current at 5 volts. I cannot trust that. No one can trust a Chinese device. I can guarantee you this thing can only deliver up to 500 milliamps. 1 amps for this one for 15 rupees. I don't know. Even if you try to draw 1 amp, it may catch on fire or something. But when he gave this to me, it is not working. So I don't know what happens is that when they are actually buying not just hundreds of them, they are buying like literally thousands of them at even cheaper price, even less than 15 rupees. So what happens is, if something goes wrong with these units, they cannot return back to China. They cannot return it. There is no warranty or anything. So what they can do is they can just trash it. Yes, they are just throwing it in the trash, and later some cleaning people will come and take this away to discard it somewhere else. So enough of talking, let's open it. So let's see how the inside of a 15 rupees charger looks like. Okay, so this thing is not working. So okay, oh, it is hard. Oh, oops. Okay, I now have completely removed, but okay, but that something curious happened. If you take a look at the wire, you can see only one of the wire that actually came out. The other was just sitting like that inside. I mean, is that like what happened? I don't know. Anyways, let's just push that out. I mean, was that wire actually connected to this thing at all? I mean, if I pulled it, then both of the wires should have come out, because that's both of the wires are connected to this. So when I pull it out, certainly both of them has to come out, right? But only one wire came out. That suggests that this wire was not connected to this thing. I don't know. Let's take a look at the soldering. I don't know whether you can see it. Can I focus on it? Yes, just look at the soldering that they used. Like, the wires just came right out of the solder joint. The wires were just sitting on top of this. So that explains why it came out really quick. See that? Those tracks. Anyways, now I have something to solder back, and because this thing was not working, I don't even care to actually make this thing work back again. But something, I mean, there is nothing exploded. You cannot. I'm not seeing anything. Let me smell it. Nothing is wrong with this. I mean, could this be the culprit? This wire? I mean, there is no smell. When electronics burn, or when something gets wrong with electronics, you will get that characteristic smell. But it is not here in this case. So I seriously doubt that this circuit was the circuit really is okay. It is just this wire, that is my doubt. But anyway, let's test it at the last. But moving on, let's take a look at the circuit. This is a minimalistic circuit that you can find in almost all cheapest circuit. And let's see what brand capacitors they are using. Probably the Chinese, like the Chang'e or something like that. That is the possibility. What on earth is that? I don't know what. I cannot even read that. Let's see what it. Oh yeah, there it is. GK branded capacitor, whatever that is in China, and this has to be the main switching transistor. I mean, the circuit entirely is really simple. All it's happening is that in the AC mains comes in. There is no line filtering or anything. Just it comes straight to the rectifier. For the full bridge rectifier over here, yes, you can see both of the wires coming straight to the full bridge rectifier circuit. There is no fusible resistors, there is no line filtering, chokes or anything, because that costs money and they really want to make it cheap. You cannot trust the transformer at all. I mean, just look at that. If I can focus on that, let me show you. That is already broken out of the box. See that? The transformer, it is actually broken right out of the box. See that? That is broken right over there. That is the copper over there. You cannot make sure that is copper. That probably is copper coated aluminium. Anyways, this is the switching transformer. What they're actually doing is that they're switching the primary of this transformer. They're converting the AC mains to DC, and they're using this switching transistor, which is let me zoom on that if possible. This is the 13003A, which is a common transistor that you can find in most CFL circuit boards. So it's a common switching transistor over there. And what happens is it has two transistors, the S91, S9014, 9014 right there, and that's it. That transistor has to be for turning this thing off. This has to be primary sensing. There is no load side sensing at all, so the all current sensing has to be done on the primary side itself. So and this transformer has a secondary coil which is rectified by this, probably a Schottky diode, and it then goes straight to the USB, and there is a filter capacitor. And by the looks of it, it is really common arrangement that they're using. This has to be a Zener diode and a resistor across it. So whenever the output voltage try to exceed the Zener value, it shorts. The Zener actually conducts, and you can see the Zener has actually a connection that is going on to the opto-isolator. You can see that going on to here, the opto-isolator. So what happens is that whenever the output voltage goes above the Zener voltage, it actually turns on the LED inside, and that in fact activates the transistor on the other side, which is then going to probably disconnect okay. So by the looks of it, the transistor inside this opto-isolator is connected to this thing. Yeah, okay. So this thing in fact activates this transistor, which in fact turns off the main switching transistor. By that way, it is limiting the output voltage. And also this thing has to have some sort of sensing at the input for the current. But yeah, anyways, that is a 1 kilowatt 220 picofarad capacitor, 220 nanofarads, that is used for the primary and secondary side connection, interference suppression. And let's take a look at the clearance. I mean, this tip over here is like you can see that this tip over here is probably 2 millimeters. So you can see the clearance between clearance. You can actually, it is actually the creepage. Yeah, there is an EEV block video that suggests you that tells you the difference between a creep age and a clearance. So the creep age is actually the distance between the two tracks or the two terminals, and the clearance is the spacing that is between the components, in fact. So if this tip is 2 millimeters, you can actually see the clearance, the creep age across the main side, and certainly this side is the primary, the AC mains high voltage side, and towards the right side is the low voltage side, and you can see the creep age distance is hardly 1.5 millimeters. There is in fact some huge separation over here, not huge but huge, like couple of 4 millimeters something over here, but yeah, that's it. Everything else is really simple. So now I'm going to actually solder the two wires back to here, because I strongly believe that this wire was the culprit. Anyways, I'll be back once I solder back the connections. Okay guys, so I have now soldered back the wires, but I haven't turned it on. But let's turn it on in front of the camera, so if anything happens you can actually see that. I'm going to use some test leads over here, so I'm going to connect one to that and the other one just or otherwise I should have connected it that way, come on. Yeah, I now have connected those two things. Okay, I'm just going to pause. Okay guys, so here I have connected it to a mains power cord. So I'm going to plug this in and you are going to see what happens live in front of the camera. In 3, 2, 1. Okay, seems like there is no smoke or anything, and I'm not hearing at all. So I'm thinking that there are two possibilities. Either this thing has now started working, or this thing is not at all working. So, but I'm not going to plug in my USB power meter to this at all without testing it properly, because I'm not risking it. I don't want to lose this thing. So I'm going to use a USB light like this one. This one is only 10 rupees. So even if it got burned off, I'm not caring about it. So I'm going to just plug this in. Ooh. You cannot trust Chinese electronics even after turning it off. I'm just going to zoom a little bit back up so you can see what is happening. Now I'm going to plug it back in and let's see what happens. In 3, 2, 1. There it is. Okay, finally. Now it is working. So that was my doubt was actually true. It was that single wire that was causing the issue. And considering the fact that he told me that this thing was not working at all, so basically that clarifies the issue. So now let's see whether it is capable of actually providing the 1 amp of current that it promised. Let me make sure that the switch is off. Yes, it is. So I'm going to even after turning, I'm still a little bit worried. So I'm having the confidence to plug my meter in. Okay, so I'm going to turn it on, and there it is. Okay, so it's giving out 5 volts at 0 amps, and there's my USB load. Yeah, there it is. I'm going to plug in my USB load, and I'm going to, right now it is in 1 amp position. So let me just, I'm turning it on, and yes, it is actually providing 1 amps at 4.9, like 5 volts. That's really good. I mean, even though the fact that this thing is entirely cheap at 15 rupees, it still is capable of delivering the 1 amps current that it is designed to. So now let's actually turn the switch to 2 amps. Let me just use something to do that. I'm not going to touch that thing, because you cannot trust Chinese electronics. I'm going to use this screwdriver to turn the switch to 2 amp mode, and there it goes. It is not It is not designed, certainly not designed to handle. You can see the voltage has dropped to around 3.3 volts, and it is only capable of providing up to 1.5 amps max. You can barely see that here. Maybe you cannot see that on the camera, but I saw that it was 3.3 volts at 1.5 amps, and it is slowly recovering from that. See that? So it is capable of delivering 1.1 amps at 4.9 volts. So it is good. Let me just turn this off, unplug it, and turn the rest of stuff. Remove the stuff from it. Yeah, come on. Yeah. So yeah, for 15 rupees you are getting something that is really cheap. You cannot trust even though the creepage distance is really bad, and also you cannot trust the winding of the transformer, you still can use this thing for lighting up an LED or something like that. Don't ever use this thing for charge your cell phones. Okay, don't. If you really want to use your valuable electronic device for many long years, don't use this thing. But this thing is certainly good for small stuff like this one, or a USB fan, or something that is you don't actually care about. You can certainly buy this, and of course you can buy it for parts also. You know that for 15 rupees buying this for the transistor alone is worth that much. I think, you know, the USB terminal, the transistor. Yeah, pretty much that's it. That's for today's video. Thanks for watching. See you in another video.